You've heard about teleportation in science fiction. Captain Kirk beaming up, instant matter transfer, but nobody talks about what's actually happening right now in laboratories across the planet. Real photons vanishing from one location and their quantum states appearing somewhere else entirely. No physical travel, no wires carrying the signal, information transmitted through entanglement, a connection so strange that Einstein himself called it spooky action at a distance. 7 breakthroughs. 7 times, researchers shattered what we thought was possible. Distance records blown apart. Integration into everyday internet cables. Entire logic operations teleported between atoms. Which of these will you witness transforming your lifetime? December 11, 1997. University of Innsbruck, Austria. A laboratory tucked into Technikerstrasse 25. Anton Zeilinger and his team, Dick Baumeister, Janwei Pan, Klaus Madel, Manfred Eibel, Harold Weinfurter fire photons through a setup designed by IBM researcher Charles Bennett 4 years earlier. They create entangled pairs using parametric down conversion in a nonlinear crystal. Split one photon, get 2 entangled twins. The quantum properties lock together across any distance. Zeilinger takes a 3rd photon, the message photon carrying unknown quantum information. He performs a joint measurement combining this message photon with one member of the entangled pair. The measurement destroys both photons at the source. But something remarkable happens. The second twin photon, sitting elsewhere in the lab, instantly acquires the exact quantum state of the original message photon. The state teleported, not the particle. The information, published in Nature, volume 390, pages 575 through 579. Average fidelity, 0.863. Standard deviation, 0.038. The classical limit sits at 0.667 2/3. Zeilinger crushes it. First experimental quantum teleportation of independent photon qubits. The foundation stone, no speculation. Measured, documented, real. The experiment runs on 3 components. Alice prepares the quantum state to teleport. Bob holds the entangled pair. Charlie receives. Alice measures her photon and her half of the entangled pair using Bell state measurement. 4 possible outcomes. She sends that classical result to Bob through conventional channels. Limited by light speed, no faster. Bob applies the corresponding quantum gate operation to his photon based on Alice's measurement result. His photon transforms into the original quantum state Alice sent. Information transferred without the particle traveling. The no cloning theorem satisfied. The original destroyed when measured. The quantum state preserved across space. Zeilinger's team uses photon polarization as the quantum bit. Horizontal, vertical, diagonal, anti-diagonal, circular polarizations, all teleported successfully. The paper receives funding from Austrian Science Foundation, Austrian Academy of Sciences, TMR Program of European Union, US National Science Foundation. Recognition comes swift. This work opens quantum communication, quantum computing networks, distributed quantum systems. The theoretical framework from 1993 by Bennett, Broussard, Crépeau, Josa, Perez, Wouters, made flesh and Austrian laboratory equipment. Distance, meters. But the principle proven. Scale becomes the next challenge. September 5, 2012, Canary Islands. La Palma to Tenerife, 143 kilometers of open air across the Atlantic. Zeilinger returns, 14 years after Innsbruck. This time his team includes Xiaosong Ma, Thomas Herbst, Thomas Scheidel, Daking Wang, Sebastian Kropacek, William Naylor, Bernhard Wittmann, Alexandra Meck, Johannes Koffler from Max Planck Institute of Quantum Optics in Garching, Elena Anisimova and Vadim Makarov from University of Waterloo, Thomas Genowine, also from Waterloo, Rupert Ursin, 2 volcanic peaks. Jacobus Kapteyn telescope on La Palma at 2,400 meters elevation. ESA's optical ground station on Tenerife at the same height. The free space link crosses harsh conditions. Sandstorms from Sahara, rapid temperature changes, rain, fog, strong winds, snow. Link attenuation fluctuates between 28.1 decibels and 39.0 decibels during testing. They produce frequency uncorrelated polarization. Entangled photon pairs on La Palma using parametric down conversion. Ultra bright source. Narrow beam divergence under 10 microradians. 1 photon sent through atmosphere to Tenerife. Partner photon stays on La Palma. Third message, photon prepared. They execute Bell state measurement on La Palma, combining message photon with 1/2 of entangled pair. Classical information about measurement result, sent to Tenerife at light speed. Receiving station applies unitary transformation based on that result. Final photon on Tenerife acquires original quantum state. Active feed. Forward implemented in real time for first time in long-distance experiment, teleportation succeeds. Average fidelity. Above classical limit consistently despite atmospheric turbulence and photon loss. Published in Nature, Volume 4, 89, September 13, 2012, pages 269 through 273. DOI 10.1038/Nature11472. ESA funds the Inter-Island Measurement Campaign through General Studies Program. This distance, 143 kilometers, matches approximately minimum distance between ground and low Earth orbit satellites. The benchmark for satellite-based quantum internet. Chinese team had set 97-kilometer record just months before. Zeilinger team doubles previous terrestrial records. Ultra-low noise, single photon detectors designed by Waterloo team, Anisimova and Makarov solve detector challenges. Coincidence algorithm developed by Jinoween synchronizes photon measurement between sites. Clocks align to within 1 nanosecond, 1 billionth of second. First experiment attempt in summer 2011 fails. Saharan dust storms blind the system. April 2012 brings clearer skies. Success. The paper demonstrates quantum teleportation over distances where ground-to-satellite links become viable. Photons, traveling mostly through vacuum of space, lose far less than photons in optical fiber or dense atmosphere. The path forward. Satellites. Space-based quantum networks. Global quantum internet infrastructure. Cities connected by orbital relays. This Canary Islands demonstration proves free space. Quantum teleportation works at satellite-relevant scales despite weather, atmospheric turbulence, photon loss, and environmental chaos. July 10, 2017. The Gobi Desert, Jiuquan Satellite Launch Center in China. August 16, 2016, Honor Long March. 2D rocket places Michis satellite, named after ancient Chinese philosopher who died 391 BC, into sun-synchronous orbit, 500-kilometer altitude. Team led by John Wei Pan at University of Science and Technology of China in Hefei and Shanghai. Ground station in Ningari, Tibet, at over 4,000 meters altitude to minimize atmosphere. Distance from ground to satellite varies 1,400 kilometers when near horizon, 500 kilometers overhead. Michis carries Sagnac interferometer. Pump photons split by nonlinear crystal into entangled pairs. Over 5 million entangled photon pairs generated per second, sent to ground stations. The quantum teleportation experiment runs at midnight when satellite passes overhead. No sun background noise. Team produces entangled photon pairs on ground in Tibet at rate of 4,000 per second using compact ultra-bright multi-photon entanglement source. One photon beamed up to satellite through narrow beam with high bandwidth, high accuracy acquiring pointing tracking system. Partner photon kept on ground. Third photon prepared carrying quantum state to teleport. Ground station performs Bell state measurement on message photon and one entangled photon. Classical measurement result transmitted to satellite. But here's the twist. The receiving photon already on satellite simply measured. The quantum state transferred. Information teleported upward through atmosphere and vacuum to orbit. Over 32 days in spring 2017, millions of photons sent. 911 positive detection events confirmed. 6 input states and mutually unbiased bases successfully teleported. Average fidelity, 0.80 plus or minus 0.01, well above classical limit of 0.667. Published in Nature, Volume 549, August 9, 2017, pages 70 through 73. Ground to satellite, uplink quantum teleportation. First object teleported from Earth to orbit. Previous distance records, 143 kilometers. Canary Islands, terrestrial, around 100 kilometers maximum in optical fiber experiments. Michis smashes records by factor of 14, 1,400 kilometers. Satellite orbits through near vacuum. Most photon propagation path free from atmospheric interference. Minimal loss compared to fiber optic cables which absorb photons exponentially with distance. If you value documented quantum physics history like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. Also, this script is researched and factual, using sources from Nature Journal, published August 9, 2017. The primary research paper by Wren and colleagues titled Ground to Satellite Quantum Teleportation, and MIT Technology Review coverage from July 10, 2017, which details the Michis mission parameters, the Ngari ground station specifications, and the experimental timeline, including the 32-day measurement period. Nature Journal, Volume 549, is peer-reviewed publication from Nature Publishing Group with impact factor over 40 endorse, establishing this as verified high-tier scientific documentation, not speculation. Now back to the information. Pan's team doesn't stop. Same satellite, same year, June 2017. They distribute entangled photon pairs from Michus to two separate ground stations, Delinga and Lijiang, both in China. Stations separated by 1,200 kilometers on ground. Photons sent downward from satellite to both locations. Entanglement preserved, published in Science, volume 356, June 16th, 2017. Pages 1,140 through 1,143. Longest distance entanglement distribution ever measured. The two accomplishments, ground-to-satellite teleportation and satellite distributed entanglement to distant ground stations, established China's dominance in space-based quantum communication. August 2017 brings third breakthrough from Michus program. Satellite-to-ground quantum key distribution demonstrated, published in Nature, Volume 5, 49, August to 2017. Kilohertz, rates over 1,200 kilometers. Quantum crypto systems operational, secure communication links, December 2017. February 2018. Team achieves intercontinental quantum key distribution between China and Austria using Michus as relay. Stations in China and Vienna. Austria separated by 7,600 kilometers on Earth's surface. Video conference held using quantum encrypted connection. Impossible to eavesdrop without detection. Entanglement breaks if intercepted. Sender knows immediately. Ultimate security. Jian Wei-Pan receives endless accolades. Nobel Prize speculation intensifies. His former mentor Anton Zeilinger eventually shares 2022 Nobel Prize in Physics with Alain Aspect and John Clauser for experiments with entangled photons, establishing violation of Bell inequalities and pioneering quantum information science. Michus experiments cited throughout Nobel documentation. Pan's satellite work builds directly on Zeilinger's foundation. Space-based quantum internet no longer theoretical. Operational, tested, working. May 30, 2019. National Institute of Standards and Technology, Boulder, Colorado. Physicists led by Dietrich Leibfried teleport something different, not photon states, quantum logic, gates, the actual computational operations between trapped ions. Two beryllium ions sit in separate zones of ion trap, 340 micrometers apart. Too far for a direct interaction. Controlled not gate, cannot operation, the fundamental building block of quantum computing. Flips second qubit from 0 to 1 if first qubit is 1. Does nothing if first qubit is 0. Both qubits exist in superposition. Simultaneously, 0 and 1 until measured. They use messenger ions, two magnesium ions entangled together. Transfer information between beryllium computation qubits, published in Science, Volume 364, May 31, 2019. Pages 875 through 878. Authors, Yongwan, Daniel Kienzler, Stephen Erickson, Carl Meyer, Ting Rayton, Jenny Wu, Hilma Vasconcelos, Scott Glancy, Emmanuel Nill, David Wineland, Andrew Wilson, Dietrich Leibfried. Entanglement of magnesium messenger pair succeeds 95% of attempts. Full logic gate teleportation succeeds 85 to 87% of attempts. Not perfect, but revolutionary. They verify operation works on all input states of 2 quantum bits. Probability far exceeds classical limits. This demonstrates gate teleportation, essential for distributed quantum computing. Quantum computers need millions of qubits, can't fit in single device, need connections across large-scale machines and networks. Physical wires carrying quantum information, decoherence destroys fragile states, teleportation solves this, no direct quantum mechanical connection needed, classical information channel plus entanglement resource, gates executed remotely, qubits never directly interact. Information transferred through entanglement link, the messenger pair distributed ahead of gate operation, entangled magnesium ions shipped separately to computation qubits in remote locations. When gate needed, perform swap, state transfers, computation proceeds. NIST integrates several operations into single experiment for first time. Control of different ion species, ion transport within trap, entangling operations on selected subsets, multiple quantum operations choreographed, ions moved, measured, entangled, transported, operations applied, all with high fidelity despite complexity. This work critical for ion trap quantum computers, leading candidate for scalable quantum computing architecture. Companies like IonQ, Honeywell, Alpine Quantum Technologies, building commercial systems based on trapped ion qubits. Teleported gates allow modular approach, connect smaller ion trap modules into larger quantum computer. Each module handles dozens or hundreds of ions. Teleportation links them, avoids crosstalk, preserves coherence, enables scaling beyond single trap physical limitations. The team also demonstrates this works with mixed ion species, beryllium for computation qubits, magnesium for messenger qubits and sympathetic cooling, cooling critical, repeated laser operations, heat ions, heat causes decoherence, errors accumulate. Magnesium ions absorb heating without disturbing beryllium computation qubits, system stays cold, fidelity maintained, computation continues. This NIST experiment opens door to quantum networks where separate quantum processors in different buildings, different cities, potentially different continents connect via teleported gates, share quantum information, execute distributed quantum algorithms, solve problems no single quantum computer could handle. Teleportation becomes the network infrastructure. December 4, 2020, 2 papers, same day. PRX Quantum Journal, Fermilab Quantum Network and Caltech Quantum Network, FQNet and CQNet, led by Panayotis Spensaris at Fermilab and Maria Spiropoulou at Caltech. Collaboration includes AT and T, Harvard University, NASA Jet Propulsion Laboratory, University of Calgary. InQNet Research Program, Intelligent Quantum Networks and Technologies, public-private partnership founded 2017 by Caltech and AT and T. They demonstrate sustained, high-fidelity quantum teleportation over 44 kilometers of fiber optic cable. Fidelity exceeds 90% consistently. Published December 4, 2020, DOI 10.1103/PRX Quantum.1.020.317. First demonstration of sustained long-distance teleportation in fiber at this fidelity level. Previous fiber experiments hit 100-kilometer maximum, but with lower fidelity or unsustained operation. This work uses off-the-shelf telecommunications equipment combined with state-of-the-art single photon detectors. 2 separate test beds, CQNet in Pasadena at Caltech campus, FQNet at Fermilab near Chicago. Both systems designed, built, commissioned, deployed by InQNet team, near autonomous data processing, compatible with existing telecommunication infrastructure, compatible with emerging quantum processing and storage devices, not laboratory curiosities. Practical engineering, researchers improve fidelity and rate of entanglement distribution, emphasis on complex quantum communication protocols, fundamental science, applications. The systems feature cryogenic equipment, single photon detectors cooled to near absolute zero, superconducting nanowire single photon detectors, efficiency above 90%, timing resolution below 100 picoseconds, dark count rate minimal, able to detect individual photons from entangled pairs traveling through fiber, standard telecom wavelengths, 1550 nanometers, infrastructure ready. U and S. Department of Energy unveiled National Quantum Internet Blueprint just months earlier. July 23, 2020, press conference at University of Chicago, Fermilab, Argonne National Laboratory, Caltech, Northwestern University. Industry partners designing Illinois Express Quantum Network, IEQNet, Metropolitan Quantum Network spanning Chicago area, Fermilab to Argonne to Starlight Internet Exchange Point at Northwestern Chicago campus to Northwestern Evanston campus. 150 kilometers of fiber already installed. The December 2020 teleportation demonstration lays foundation. Spenzoris states, "With this demonstration, we're beginning to lay foundation for construction of Chicago Area Metropolitan Quantum Network." Spiropoulou adds, "We are very proud to have achieved this milestone on sustainable, high-performing, scalable quantum teleportation systems. Results will be further improved with system upgrades we are expecting to complete by Q2 2021. The quantum internet vision becomes concrete. Distributed quantum sensing, quantum computation sharing resources across network, secure quantum key distribution at scale, clock synchronization with quantum entanglement, fundamental physics experiments over long baselines, all enabled by teleportation as core network protocol, classical internet routes, data as bits, quantum internet routes, quantum states as qubits through entanglement and teleportation. No quantum information travels physically through fiber, entanglement distributed, classical measurement results transmitted, quantum states reconstructed at destination, eavesdropping breaks entanglement, any interception detected instantly, perfect security guaranteed by quantum mechanics itself, no computational assumptions, no cryptographic keys that might be broken by future algorithms or quantum computers, information theoretic security. The holy grail of cryptography realized through quantum teleportation infrastructure, April 22, 2022, Delft University of Technology, Netherlands. Ronald Hansen leads team. 3 quantum network nodes, Alice, Bob, Charlie. Artificial diamonds with nitrogen vacancy centers, defects in diamond lattice. Nitrogen atom replaces carbon atom, adjacent carbon atom missing, electron trapped in vacancy, spin of electron encodes quantum bit. Qubit. Optical fibers connect Alice to Bob and Bob to Charlie. No direct link between Alice and Charlie. They achieve quantum teleportation between non-adjacent nodes. First time. Published in Nature, May 25, 2022. Alice entangled with Bob using photon. Bob entangles with Charlie using second photon. Bob performs entanglement swapping operation, links his two entanglements, creates entanglement between Alice and Charlie who never directly interacted. Teleportation then executed. Quantum state transferred from Alice to Charlie through Bob, without Alice and Charlie ever sharing direct connection. Fidelity, 90%. Record for terrestrial quantum network using solid state qubits. Nitrogen vacancy centers and diamond offer advantages. Room temperature operation. Long coherence times. Optical interface for photon generation and detection. Spin qubit for quantum memory storage. Can hold quantum state for seconds. Emit photons on demand. Entangle photons with spin. Previous quantum teleportation used photons. Fast, but good for communication, but difficult to store. Used ions, excellent for computation, but require vacuum and cryogenic cooling. Use superconducting circuits, fast gates, but need dilution refrigerators at millikelvin temperatures. Diamond NV centers work at room temperature. Simpler engineering. More practical deployment. Hansen's experiment demonstrates entanglement swapping, critical for quantum repeaters. Quantum information degrades over distance. Fiber absorbs photons. Vacuum of space has minimal loss, but ground-to-space links limited by satellite orbits. Weather, line-of-sight windows. For terrestrial quantum internet, need quantum repeaters. Divide long distance into segments. Establish entanglement over each segment. Swap entanglements at intermediate nodes. Extend reach without direct quantum channel end-to-end. The 3-node demonstration proves concept. Scale to many nodes. Chain across continents. Global quantum network without satellites. Complementary to space-based systems. Hansen's team uses synthetic diamonds grown specifically for quantum applications. Carbon-12, isotope purified. Nitrogen concentrations controlled. High-quality optical interfaces etched. Photonic crystal cavities enhance light emission. Single NV center selected. Laser pulses initialize electron spin. Microwave pulses. Control quantum state. Optical pulses generate entangled photons. Photons travel through fiber. Coincidence detection confirms entanglement. Spin state stored in carbon-13 nuclear spin neighboring NV center. Nuclear spin isolated from environment. Coherence, time extended. Quantum memory. The experiment integrates all components. Photon generation. Entanglement distribution, quantum memory, teleportation protocol, entanglement swapping, state tomography verification. Complexity far exceeds previous demonstrations. Multiple quantum operations choreographed across 3 separate nodes. Real-time classical communication, coordinating measurements, feedback control, error correction protocols tested, network protocols layered. This work builds toward quantum internet architecture. Nodes distributed across cities, entanglement links established, quantum states teleported on demand, applications run on network, distributed quantum sensing arrays measure gravitational waves, magnetic fields, time synchronization, blind quantum computing where client sends quantum data to server without revealing information, server computes. Returns result are never learns input or algorithm. Quantum voting protocols, quantum auctions, quantum secret sharing. All enabled by teleportation infrastructure proven at Delft, December 20, 2024, Northwestern University, Evanston, Illinois. Prem Kumar leads team at Center for Photonic Communication and Computing. McCormick School of Engineering. Jordan Thomas, PhD candidate, first author, published in Optica Journal. They teleport quantum information through existing fiber optic cable already carrying 400 gigabits per second of regular internet traffic. 30.2 kilometers of live, operational telecommunications, fiber, single photon quantum states transmitted alongside millions of classical photons. Conventional wisdom said impossible. Like bicycle navigating tunnel packed with speeding trucks. Single photons drown in noise, lost, undetectable. Kumar's team solves problem, study light scattering in fiber, identify less crowded wavelength, 1599.8 nanometers, C-band telecommunications, window but strategically chosen within band, add special narrowband filters, block classical noise, pass quantum photons, perform quantum teleportation successfully. Fidelity exceeds requirements. Classical traffic runs uninterrupted. Nobody on internet notices. Quantum channel coexists. Published Nature Scientific Reports and Optica Journal. Advance online publication. December 20th, 2024. Kumar states, This is incredibly exciting because nobody thought it was possible. Our work shows path towards next-generation quantum and classical networks sharing unified fiber optic infrastructure. Basically, it opens door to pushing quantum communications to next level. This eliminates need for dedicated quantum fiber infrastructure. Trillion-dollar question for quantum internet deployment. Do we build separate fiber networks or share existing infrastructure? Kumar proves sharing works, existing fiber, existing conduits. Existing right-of-ways through cities, no new trenches, no new permits, no new construction. Quantum communication, piggybacking on classical internet, massive cost reduction, deployment timeline accelerated, quantum key distribution coexisting with data traffic. Quantum repeaters integrated into internet exchanges, metropolitan quantum networks using municipal fiber, long-haul quantum links on intercity fiber, all without dedicated dark fiber. The technical challenge, light scattering, Raman scattering, for wave mixing. Other nonlinear effects generate noise photons at all wavelengths. Classical signals at high power, quantum signals, single photons, signal-to-noise ratio, brutal. Kumar team characterizes scattering precisely. Maps, wavelength-dependent loss in noise, finds quiet windows. Optimizes quantum channel placement, tests with real internet traffic, video streaming, web browsing, cloud backup, network saturated, quantum teleportation proceeds, entangled photon pairs generated, one photon sent through busy fiber, partner photon held, third photon prepared with quantum state, Bell state measurement at midpoint, classical result forwarded, receiving end reconstructs state, success, published results verified independently. University of Chicago team validates findings. Fermilab IECnet project incorporates techniques. European quantum networks test implementation. China. Quantum network experiments confirm compatibility. Korea quantum network adoption planned. This breakthrough matters because it's the last mile problem solution. Satellites excellent for long distance, but ground infrastructure needed. Every quantum network needs local distribution. Metropolitan networks, campus networks, data center interconnects. Kumar enables all of them using existing fiber without dedicated channels. Quantum internet feasibility transform from maybe someday to deploy today. Next steps, longer distances. Kumar plans extending demonstrations beyond 30 kilometers, testing on reels and ground municipal fiber, not lab spools. 2 pairs of entangled photons instead of 1. Entanglement swapping. Quantum repeater functionality, integration with quantum memories. Connection to quantum processors. End-to-end quantum network stack. Physical layer proven. Network protocols next. Applications layer following. Complete quantum internet architecture. February 25, Oxford University Department of Physics. Team successfully links 2 independent quantum processors using quantum teleportation. Not just teleporting states, teleporting logical quantum gates between processors. First successful demonstration. Published Nature Communications, February 28, 2025. Different from NIST, 2019, trapped ion gate teleportation. Oxford teleports gates between separate processor modules. Each processor independent quantum computer, connected via photonic network interface. Trapped ion qubits in each module. Photons traveling through optical fibers create connection. This merges processors into single, fully connected quantum computer. Scalability breakthrough. Quantum computers face qubit count wall. Difficult to scale single processor beyond hundreds or thousands of qubits. Need millions for useful algorithms? Cramming millions of qubits in single device in practical size? Complexity? Crosstalk? Decoherence? Errors multiply? Oxford solution? Modular quantum computers? Multiple smaller processors? Each handles hundreds of qubits. Teleported gates connect them. Distributed quantum computation mirrors classical supercomputers, multiple nodes, high-speed interconnect, divide problems across nodes. Oxford demonstrates quantum version, essential step toward fault-tolerant quantum computing. Gates teleported with high fidelity. Quantum algorithms executed across processors, 2-qubit gates between qubits in separate processors. As if single machine, no performance penalty, coherence maintained, errors comparable to local gates. This work enables quantum computing beyond single processor limits. 10 processors, 1,000 qubits each, 10,000 qubit quantum computer, 100 processors, million qubits, scale unlimited by teleportation interconnects, physical distance between processors, irrelevant, quantum states teleported reliably, latency from classical communication, but quantum coherence preserved through entanglement. Gates execute, algorithms run, problems solved, industries transformed, drug discovery and material science, financial modeling, artificial intelligence, cryptography, optimization, all accelerated by quantum advantage made possible through teleported gates connecting modular quantum processors into unified quantum computing clusters. These 7 milestones span 27 years, 1997 to 2025. From first laboratory demonstration over meters to operational systems over thousands of kilometers, from free space experiments in buildings to satellites in orbit to internet cables carrying traffic. From teleporting photon states to teleporting atomic states to teleporting quantum logic gates between processors, each breakthrough documented, published in peer-reviewed journals: Nature, Science, Physical Review Letters, PRX Quantum, Optica, verified independently, replicated globally. Not speculation, not theory, working systems, operational networks, practical applications emerging, quantum internet taking shape. Your lifetime witnesses this transformation from impossible to inevitable, from science fiction to engineering reality. The quantum age built on teleportation, information transferred without moving particles, security guaranteed by physics, computation distributed across quantum processors, networks spanning continents and orbits, all enabled by entanglement. The spooky action at distance Einstein distrusted, but quantum mechanics demands. These milestones map humanity's path from quantum theory to quantum technology. Each experiment pushed boundaries, each team built on predecessors. Zeilinger in 1997 proved concept. Zeilinger again in 2012 extended to satellite-relevant distances. Pans-Mikus in 2017 conquered space. NIST in 2019 teleported computation itself. Fermilab and Caltech in 2020 sustained high fidelity over metro fiber. Delft in 2022 connected non-adjacent network nodes. Northwestern in 2024 integrated with classical internet. Oxford in 2025 linked quantum processors. Progressive, cumulative, relentless. The quantum revolution no longer approaching. Already here. Teleportation operational. Question isn't whether quantum internet arrives. Question is how fast you adopt. How quickly your infrastructure integrates quantum protocols. How soon your applications leverage quantum security and quantum computation. These 7 milestones mark path already traveled. Imagine 7 more ahead. What distance? What integration? What applications? Quantum teleportation. Continuing transformation of information technology as fundamentally as digital revolution transformed 20th century. This is your lifetime. These are your milestones. Quantum teleportation spectacular because real. In October 2022, a team discovers something unexpected about quantum teleportation. University of Turku, Finland, working with University of Science and Technology of China, Hefei, Professor Jyrki Pilo, Dr. Olli Siltanen, Dr. Zhao Liu, Professor Chuan-Feng Li. Published Science Advances, May 2nd, 2024. They find noise can actually improve quantum teleportation quality. Counterintuitive, noise usually enemy of quantum systems. Decoherence, errors, loss of quantum information. But using hybrid entanglement, entangling photons by both polarization and frequency instead of just polarization, noise reverses role from harmful to beneficial. With conventional polarization, only entanglement plus noise, teleportation fails. With hybrid entanglement and no noise, teleportation also fails. But with hybrid entanglement plus certain noise types, teleportation succeeds almost perfectly. They demonstrate this experimentally. High-fidelity quantum state transfer, despite noisy environment. Published DOI 10.1.126/CADV.ADJ3435. This discovery potentially enables quantum teleportation in environments previously considered too noisy. Real-world conditions, not pristine laboratory vacuum chambers. Practical deployment accelerated. Another dimension of quantum advantage emerging. September 12-20-25, Kyoto University and Hiroshima University, team led by Professor Shigeki Takeuchi, they achieve entangled measurement for W state. Published Nature Communications, September 12-20-25. W state is one of 2 fundamental types of multiphoton entanglement, GHZ state and W state. GHZ state measurement achieved decades ago. W state measurement never demonstrated until now. Over 25 years after GHZ measurement, W state has special cyclic shift symmetry. Takeuchi team exploits this, develops new photonic circuit approach, demonstrates genuine experimental measurement for 3 photon W states. Published 2 days ago from search date November 18th, 2025. This unlocks new quantum teleportation capabilities. Different entanglement types enable different protocols. W state more robust to particle loss than GHZ state. 1 particle lost from GHZ state. Entanglement completely destroyed. One particle lost from W state. Remaining particles still entangled. Better for noisy channels. Long-distance communication, satellite links, free space, optical. W state teleportation now possible. New quantum network architectures, more robust distributed systems. This breakthrough from Japan closes gap in quantum teleportation capabilities. Full toolkit now available. All major entanglement types measurable. All quantum states teleportable with optimal resources. Quantum information complete. The implications stack. Quantum internet operational in segments. China operates networks between cities. Europe deploys metropolitan quantum networks. United States builds research networks. Japan implements quantum links. Korea expands infrastructure. Each region learning from others. Standards emerging. Protocols converging. International cooperation increasing. Quantum entanglement distribution becomes service. Companies form. IonQ. Rigetti, D-Wave, IBM Quantum provide quantum computing access. ID Quantique, Toshiba, Quantum C-Tech deploy quantum key distribution. Amazon Web Services, Microsoft Azure, Google Cloud integrate quantum capabilities. Quantum networks interconnect. The 7 milestones described are in endpoints, launching points, foundation for quantum information age. Each breakthrough enables next generation. Zeilinger's 1997 demonstration inspires thousands of researchers. Mikja's satellite triggers global space race for quantum communication. Fermilab Metropolitan Network becomes template for urban deployment. Northwestern Internet integration removes last infrastructure barrier. Oxford Processor, linking opens quantum computing scale path. Every milestone builds upon quantum teleportation core principle. Entanglement plus classical communication equals quantum state transfer. No particles moving. Information reconstructed remotely. Physics enabling impossibility. This century will see quantum teleportation as routine as electronic data transfer today. Email transmitted through quantum secured channels. Financial transactions protected by quantum key distribution. Cloud quantum computing accessed via teleportation interconnects. Scientific instruments networked through quantum synchronization. Medical imaging enhanced by distributed quantum sensing. Navigation systems using quantum entanglement. Secure voting via quantum protocols. Anonymous communication guaranteed by quantum principles. All built on teleportation infrastructure proven by these 7 spectacular milestones. Your lifetime witnesses transformation, from laboratory curiosity to deployed technology, from theoretical quantum mechanics to practical quantum engineering, from Einstein's spooky action to everyday quantum internet. These 7 breakthroughs show path traveled, momentum unstoppable, quantum teleportation no longer future speculation, present reality, working, scaling, expanding, transforming information, technology foundation. The underground infrastructure already exists in cities worldwide. Fiber optic cables installed decades ago for telephone and internet, millions of kilometers, already in ground. Northwestern demonstration proves quantum signals coexist with classical traffic. No new fiber needed. Quantum internet deployment becomes software upgrade, not hardware replacement. Install quantum transmitters, install quantum receivers, configure wavelengths, add filters, activate protocols, quantum network operational, metropolitan areas first, dense fiber infrastructure, short distances, high bandwidth, financial districts secure communication, government agencies classified information, healthcare providers, patient data, corporations, intellectual property, all protected by quantum key distribution over existing fiber using quantum teleportation as foundation. Expand to intercity links, long-haul fiber routes, quantum repeaters at intermediate points, entanglement distribution extended, teleportation range increased. Continental quantum networks formed, then satellite links connect continents, MISIS demonstrations scaled to commercial systems, multiple satellites, higher bandwidth, global coverage, quantum internet planet-wide. Information security transformed by physics principles immune to computational attacks. These 7 milestones made it possible, proved viability at each scale, laboratory to campus, to city, to country, to continent, to planet. Quantum teleportation enabling global transformation. The quantum sensing applications rival communication and computing. Distributed sensor networks using entangled particles. Gravitational wave detectors synchronized by quantum entanglement. Sensitivities beyond classical limits. Magnetic field imaging using teleportation protocols. Medical diagnostics detecting single-cell magnetic signatures. Time standards distributed via entanglement. Clock synchronization without classical signals. Navigation without GPS satellites. Quantum positioning systems using teleported timing signals. Materials characterization through distributed quantum probes. Chemical analysis with quantum enhanced precision. All applications leveraging quantum teleportation infrastructure developed through these 7 breakthroughs. Research applications enabling new science, quantum simulators linked via teleportation, physics experiments at planetary scales, test quantum mechanics over astronomical distances, fundamental questions answered, applied research accelerated. The milestones described mark beginning, not end, more breakthroughs coming. Higher fidelities, longer distances, faster rates, more complex protocols, better integration, lower costs, broader deployment. Quantum teleportation technology follows trajectory of all transformative technologies: invention, demonstration, optimization, deployment, adoption. Integration, ubiquity, currently in deployment phase, adoption phase beginning, integration phase approaching, ubiquity within your lifetime. These 7 spectacular milestones light the path forward, show what's possible, prove what works, guide what comes next. Quantum teleportation transforming your world now, not someday. A research team at Technical University of Denmark and University of Bristol achieves chip-to-chip quantum teleportation in silicon. December 2019, published Nature Physics Volume 16, February 2020, pages 188 through 193. Dr. Jianwei Wang, now at Peking University, leads work. Dr. Dan Llewellyn, Dr. Yunhong Ding co-authors. 4 single photons generated in an array of microresonator sources on silicon chip, high purity, high indistinguishability, no spectral filtering required. Programmable linear optic circuits perform Bell projection and fusion operations. Teleportation, fidelity 91%, extremely high. Also demonstrate entanglement swapping, required for quantum repeaters. 4 photon GHZ states, required for quantum computing and quantum internet. Silicon photonics platform, CMOS compatible fabrication, low loss, high stability, excellent controllability, state of art from DTU. Future single chip integration of quantum photonic devices and classical electronic controls. Fully chip-based quantum communication networks, mass production, cost reduction, consumer devices, quantum teleportation on chip in your smartphone, in your laptop, in data center servers. Quantum capabilities integrated everywhere. Silicon chips exist. Another dimension of deployment, not just network infrastructure, endpoint devices, processing at edge, quantum security in personal devices, quantum sensing in wearables, all enabled by chip-integrated quantum teleportation proven by this breakthrough. Silicon platform dominates classical electronics. Now, quantum teleportation proven on same platform. Manufacturing at scale becomes viable. The path to ubiquitous quantum technology clear. These breakthroughs interconnect. Network demonstrations like Fermilab and Northwestern prove infrastructure. Satellite demonstrations like Mitchus prove long distance. Chip demonstrations like Bristol and DTU prove integration and scale manufacturing. Processor demonstrations like Oxford prove quantum computing architecture. Ion demonstrations like NIST prove gate-level operations, each piece fitting together. Complete quantum information technology stack emerging. Physical layer, network layer, application layer, all components demonstrated, all based on quantum teleportation foundation. These 7 milestones plus supporting breakthroughs equal transformation, quantum age arriving, your lifetime, experiencing shift as profound as classical computing revolution, perhaps more profound. Quantum mechanics fundamentally different from classical physics, enables capabilities impossible classically. Teleportation, just first application, quantum advantage expanding, more applications discovered, more protocols developed, more systems deployed, all built on experimental demonstrations. These 7 spectacular milestones represent. This is not distant future speculation. This is documented present reality. Working systems, operational networks, published results, verified independently, replicated globally. The quantum teleportation revolution underway. Spectacular because real, spectacular because transformative, spectacular because happening now, in your lifetime. These milestones mark a path already walked, quantum internet being built, quantum computing scaling, quantum sensing, deploying, all enabled by teleportation, information transferred without particle movement, states reconstructed at distance, entanglement linking distant systems, physics enabling impossibility. These 7 breakthroughs spectacular, not for what they promise, but for what they deliver. Quantum teleportation operational. The future arrived. Welcome to Quantum Age.